What is today going to be about? So really, analytical geometry or XY geometry is all about geometry on the Cartesian plane. And the Cartesian plane is just a grid where the horizontal axis is called the x-axis and the vertical axis is called the y-axis. And on this axis, we have a whole bunch of points. So let's say we have the point up here. We would go one across, and then we would go, how many up? We would go 2, 3, 4. So we went one across and 4 up. And that point over there is called a coordinate point or an XY pair. Now, we are going to be doing geometry on this grid, and we're going to use algebra to do the geometry. And so that's why this section is often called analytical geometry or XY geometry or coordinate geometry. It's basically doing geometry using algebra, and the way we do algebra is we use this grid. So give me a thumbs up if you've seen this coordinate grid before, you feel fairly comfortable using it, or give me a score out of 10, like 10 if you feel very comfortable using a grid, 0 if you don't feel comfortable, 5 if you're somewhere in the middle, because our geometry is going to go down on this space. Okay. All right. Pop in what your score out of 10 is. How confident do you feel about navigating this Cartesian plane thing? Give you your score out of 10 there. Okay. So what we're going to do today is we're just going to practice a little bit getting comfortable with coordinates, and then we're going to move on from there once I feel like everyone is comfortable. Okay, here is your first question of the day. There is a point A sitting on the grid. You need to choose which option is the correct one for the point A, which coordinate pair below is correct. I want you to try and do that for me now. So it feels like it goes 1, 2, 3, 4 across and 2 up. So the answer would be, the X always comes first, so it's 4, 2. Okay. I like this game, so I'm going to do it again. So I'm going to say, instead of the A being here, I'm going to cross this A out. And now what I'm going to do is I am going to do a new A. And this new A is going to be over here. Which option corresponds to the new A? Which option corresponds to the new A? Pop your answers in the chat. So here, we seem to be on the right-hand side. So we go 1, 2, 3, 4, and then we go 2 down. So it should be 4 across and 2 down, which is -2. And so D would be the correct answer. Okay, I want to do this one more time. I like this exercise. What if I put A over here? Which option would be correct if A was over there? Okay, so I can clearly see you guys know this like super well. So C is -4, so 4 across, 2 up. So you know how to navigate the Cartesian plane. So that's awesome. So top notch for you guys. Let's just do another one like this. What are the Cartesian coordinates of the point C? So where is C sitting down there? You have to be careful with this one. So C is sitting all the way down here. What I like to do is I draw a line straight up for that one, and then I draw a line straight across for that one. And I remember that the X always gets written first. So it's -2, and then the Y comes second. So that's -3. So is there a -2, -3? Yes, there is. It is A. So it's going to be A. Now, each of these quadrants get names. So let's see if you know the names. You probably do know them from trig, but let's have a quick look. In which quadrant do you find the point -3, 4? Now, this assumes that you know what each quadrant is, but I'll give you a hint from trig days. This is quadrant 1, 2, 3, 4. Which quadrant is the point -3, 4 in? Okay, let's have a look. So if I start, you always start at the origin and you go 1, 2, 3 across to the left, and then you would go 1, 2, 3, 4. So I guess the point would be up here. So what quadrant do you think that's going to be? Lock in your answer. The people must vote. So to me, it has to be, the answer has to be B, or the second quadrant. Now, I like this question because it tests your thinking. So I'm going to make another one. So instead of it being -3, 4, you need to tell me what quadrant is the point 4, -3 in. So what quadrant is the point 4, -3 going to be in? So it would be 1, 2, 3, 4 across, but then 3 down. And so it must be quadrant 4, or in this case, it's D. Okay. I think everyone is doing very nicely. So nicely done, Anushka, Quena, Obnejo. Very nice. So what we need to do now is we need to learn a new skill for the Cartesian plane. So you guys have been doing super, super well. But now what happens is we don't just deal with one point with analytical geometry. We often have 2 points. So let's set up a situation where we have this going on. So let's have a Cartesian plane. And what we're going to do is we're going to say this is a point over here. And this is a point, let's say, over here. It's over here. And we'll call this point A. And we'll call this point B. And what's more, I can see on my grid, the point A is 1, 1. And the point B is 1, 2, 3, 4 across. 1, 2, 3, 4, 5 up. So the point 4, 5. The problem that we need to look, the new tool that we have to learn about is something called the distance formula. And the distance formula literally helps us understand how to measure the distance between 2 points on the Cartesian plane. Now, all the distance formula does is it uses an old friend of ours to help us out. And the notation that we're going to use is distance between the points A and B is equal to whatever it is. Okay, but I want to ask you, can you see, let me get a darker pen here. Can you tell me how far, just by counting the blocks, is the blue line? And how far, by counting the green blocks, is the green line? So you can put it in the chat. What is blue? How far is blue? If you just count the blocks, can you see the blocks on the? So 1, 2, 3. So I think that this is 3 units, or 3 blocks. How many blocks does the green side count or climb? So to me, it looks like it climbs 1, 2, 3, 4. Okay, so we'll say that's equal to 4 units. But now I'm having a bit of a flashback to earlier mathematics, because if this is 4 and that's 3, and what's more, this is a right angle, do I know what AB is going to be? How would I work out, what mathematical tool would I use to help me find AB? Can anybody, I'd love to hear someone's voice, someone who can really help me nail down what is that length going to be without thinking further than that. It's an ancient Greek name. Well, it's not that ancient, I guess, but well, it is pretty. So it is going to be, have you heard of the theorem of Pythagoras? It says that the longest side squared, so AB squared, is equal to 3 squared plus 4 squared. And that is called the theorem of Pythagoras. It says the longest side in a triangle, the longest side opposite a right angle squared is equal to the sum of the other 2 squared. So if I do this, I'm going to get that. What is AB going to be? What is AB going to be? So if AB squared is 25, I think we need to square root both sides to get AB. So what is AB going to be? No problem, Nomfundo. Just remember to watch the recording that you, catch up. Yes, Abnejo. Yes, Bukle. And yes, Anushka, it's 5. So this thing is 5. Well, let me use a different color just for effect, for dramatic effect. So this thing is 5. That distance is 5. And so we can say that thing is 5. Now, basically what the distance formula does is it takes the theorem of Pythagoras and it just applies it to any 2 points. But this was a little bit clumsy. So what I'm going to do is I'm actually going to show you a formula that you can use that will do this automatically. Okay, and the way the formula works is the following. Let me get my markers out. D for distance equals something squared plus something squared square rooted. Now you may say to yourself, where are those squares coming from? But if you look at the Pythagoras' theorem, doesn't it have something squared and then something squared? And then at the very end, we have to square root both sides to get AB by itself. So this is the first part. Then what we do is inside this first bracket is the change in x. So the change in x can be written down as x2 minus x1, and the change in y can be written as y2 minus y1. So in my drawing, the blue bit was the 3, and the green bit was the change in y. That was 4. And so this is the formula that I need you to write down. So just take a moment to write down this formula in your book. And then I want to show you how I can use it with these 2 points. So my original point was the point 1, 1, and B was the point 4, 5. Instead of doing this whole long complicated thing, I could have just done this. I could have said that squared plus that squared. And then I would have said, okay, you have a choice. I'm going to choose the second point, but it doesn't really matter. I'm going to go 4 minus 1. So 4 minus 1. And over here, I'm going to go 5 minus 1. And what you'll then notice is that you get, this is going to be 3 squared is 9, 4 squared is 16, and so this is going to be 5. And look how nice and quick that was. So I'm going to give you a moment to write this down or take a screenshot. Are there any questions from the class? Because this is what we're going to practice going forward now. is applying this new thing called the distance formula. And all it does is it finds the distance between any 2 points. Give me a thumbs up if you're feeling like you understood that. Give me a thumbs up if you feel like you understood that. Fantastic. Okay, take a screenshot if you need extra sort of thing. But I think now what we want to do is we want to take this out to the races here. Now, this is a little bit of a look. Let's have a look here. Okay. So, it's a bit of a tricky one, but we're going to do it together. Just to remind yourself, let's ask the class, what are these funny square root 17, square root 2, square root 10 things? We spoke about them in the first topic of the year. What are they called when we have a square root of something that we can't square root? Okay, yes, they are called surds. These are called surds. And don't worry, they're just numbers. You can get them if you need to in your calculator. But because our distance formula has a square root in it already, sometimes surds pop up. So I want you to take this formula and I want you to try and apply it to this, where my first point is -2, 5, and my second point is 4, -3. If it helps you maybe to think about this being x1, y1, and this being x2, y2. And then I want you to try and choose an option that you think goes with this. And if you need some help, just pop your hand up and I will take a question. So I always like doing this so that I know that I'm on the right track. There's some sneaky minus signs that are going on here, though. So which option do we think is the correct one? Which one do we think is the correct one? Okay, so it looks to me like this square root of 100 would be 10. And so the correct answer is actually the length 10. So there's a distance of 10 units between this. But I think a lot of people would have got caught out by this. When you have 4 minus minus 2, it actually becomes 6, because minus a minus is a plus. And then over here, -3 minus 5, well, -3 take away 5 is -8. But when you square -8, it becomes a positive. And so sometimes that can catch students in terms of these types of questions. Okay, take a screenshot if you need to. I'm going to do one more question before we have our break. But I'll give you a moment more just to get that working. Now, obviously, you can always go back to the video too if you need to, the recording. So let's have a look at this. Oh, sorry, that's a bit big. Okay, so it says, okay, what is the radius of the circle? I'm not interested in the radius for now. I'm changing the question. I just want to know what is the diameter. So forget about answering this question for now. All I want to know is what is the distance between these 2 points on the opposite ends of the diameter. So basically, this will tell you how to work out. I want you to find the distance between these 2 points. So you have the point minus 3, 2, and you have the point 12, 10, and you have the distance formula, which basically just says that. I want you guys to work out what is the distance between these 2 points. And then I'll pop an answer in the chat. Sometimes it can be good to also just draw a line connecting the 2 x's. Because you know the y's go with the y and the x's go with the x. I might need some help from those calculator ninjas out there. I think this is 225, and I think this is 64, which gives me 2. What do we get there? We get 285, 289, but that needs to be square rooted. What is the square root of 289? It is going to be what? So let's just go back and make sure we've got this. So this bit over here becomes a 15. This bit over here becomes an 8. And then after we square root that, we get 17 units. Okay, so we know that the diameter is 17 units. Now, I'm ready to answer this question. If you know that the diameter is 17 units, how big is the radius? So how big is the radius, and which option would correspond to the radius in this question? Can you remember the relationship between the diameter and the radius? So if we have a circle and we had these 2 points, and you have just worked out that the distance along here was 17. Now I want to know what is the size of a radius. All you're going to do is take the 17 and divide it by 2. Now I don't see that here, but I do see 8.5, which would be C. Nice, Mfundo. Nice, Anushka. Okay, everyone. So part 1 today was getting familiar with the Cartesian plane, doing geometry on the Cartesian plane, and mastering a new tool called the distance formula. We are going to take a break. So I want everyone to turn their cameras on. I want you to stand up with me, and we are going to do some exercise, because we know that if we take care of our brain will take care of us. And I know some of us feel a bit like, I don't want to do this. But if you want to learn well, you have to train with the best techniques. And we know that after half an hour sitting, your brain starts to go, and it stops caring. Whereas if you get up and you force your brain to take a break and you get your body moving, your brain will reset itself and you'll get more learning for the time that you spend. Okay, let's start with some deep breaths. So let's start with just breathing in. Breathe in. Okay, so got a bit of oxygen. Now we're just going to loosen up. Our bodies have been sitting, they're passive. So shake your arms around like you're in drama class or somewhere where it's very expressive. I know some people get a bit of a shock being in maths doing this, but maths teachers also have bodies. We have to move them around. So let's do it. Let's shake it around a bit, get nice and loose. And then let's have our arms out, and we're just going to twist gently. And as we relax, we'll feel that we naturally we'll rotate further because we're just, there we go. Okay, and then one more shake, shake, shake. Last thing we do is to really wake our body up. We want blood flow, and so we're going to do jumping jacks. The jumping jack is just like this. Make sure you're not going to whack anything or anyone, and we're just going to do 10 of them. In 3, 2, 1, let's go. 2, 5, 6, 7, 8, 9, 10. And our power break is over. We're just going to do one quick little riddle, and then we're going to get back to the maths. So, actually, this is a bit of a sneaky one, but anyway. What do you think the answer to this? So if 7 people meet each other and each shake hands only once with each of the others, how many handshakes will there have been? You can submit your guess or your thoughts. I'm not actually going to have time to explain this to you today, but it's a good riddle. It's a good, I can maybe give you a little bit of a hint by drawing 7 people. 1, 2, 3, 4, 5, 6. So like if each person, that person maybe shakes hands with all those people. And then now if I go to the second person, well, that person is already shaking hands. So that'll be 1, 2, 3, 4, 5. So I'll give you a bit of a hint. 6 plus 5 for the first, but now you have to keep going. How many handshakes do you think it's going to be? Okay, I'll give you another hint. So we did this person here, that was the red, and then we did this one. The next person, like for example, this person over here, they haven't shaken hands with, they've done this person, they've done that person, but they still need to go 1, 2, 3, 4. Okay. You know what? I'll come back to this in the next lesson, but I think I've given you a little bit of a hint. Can you see a bit of a pattern about how this is happening? Okay. It's too good a question to spoil all at once. So I'm going to come back to this in the next lesson, but I just wanted to get your brains feeling a bit like mysterious. But I'll come back to the next lesson. And then also just a reminder, I did this at the beginning of the lesson, but our boot camps are starting this Saturday. Our payment deadline is tomorrow evening. And so if you want to be part of the boot camps that start the Saturday, you need to pay and have registered by tomorrow evening by 12. And if you need any more information, look at the website or contact customer service. Okay. All right, let's go back to the questions we were doing. So let's do one more. Let's not do that one. Let's not do that. Okay, let's do this one. So I want you, it says here, there are 3 different points. The coordinates of a right-angled triangle are A1 is 2, B is 3, 6, C is 7, 4. It says, what is the length of the hypotenuse of the triangle? Now, because I don't have a drawing and I'm feeling a bit confused, what should I do to get a sense of how this question is even working? Who has some ideas for me? Because I'm feeling a bit like, okay, but there's three different points. How do I know which side is the hypotenuse? What should I do to help me? Who has some ideas about how I can handle this problem I find myself in? How could I get my thinking clearer? You can pop your hand up and let me know if it's audibly, if it's easier. Otherwise, in the chat, what should I do to get my bearings? What should I do to get my bearings? I think, and I don't know if anybody else thought of this, but if I put the points on a drawing, it helps me kind of understand what's going on. So let's go with A is 1 across and 2 up. So there is A, it's the red dot. B is 3, 6. So 1, let me even maybe zoom in a little bit so it's a bit bigger. 3, 6, 1, 2, 3, 6. Okay, so that is B. And C is the 0.74. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Interesting. Okay, now, if I look at, I think I counted wrong, right? 1, 2, 3, 4, 5, 6, 7. 7 across. 2, 3, 4. No, that's fine. 1, 2, 3 across. 1, 2, 3, 4, 5, 6. So that's there, that's fine. 1 across, 2 up. Okay. So if I look at this now, do we have any idea? It says it is a right angle triangle, though I'm not 100% certain it is. Which one looks like the longest side to you? Which one looks like the longest side to you? Because the longest side, in a triangle, the biggest side is always opposite the biggest angle. So which one do you think we should find? From the drawing, it feels to me like if this is right angled, and it says it is, AC should be the hypotenuse. So I want you to use the distance formula to find me what AC is, and then I want you to tell me which of the 4 options there is correct. So go for it. Find me what the length of AC is. So I had to use my geometry skills to realize that AC must be the hypotenuse because it's opposite the biggest thing here. So I need to make sure I focus on the right points. So A and the C. I'm going to go 7 minus 1. And then I'm going to go 4 minus the 2. Now, at the moment, I don't see square root 40, but if you did the topic at the beginning of the year with Serge, you'll know that we can break down the square root of 40 into smaller pieces, and we can break this down into square root 4 times square root 10, and that can be broken down into 2 times square root 10, which gives me B. Now, your calculator can also do this, but it's also nice to know from earlier in the year that you know how to break surds down. And so the correct option would be B. All right, everyone, give me a score out of 10 in terms of using the distance formula. How do you feel if 0 is like, I don't understand anything? 10 is like, I've got this waxed easily. 5 is like, I sort of get it in the middle, but I'm not that confident. Give me a score out of 10 about how you're feeling about the distance formula. Okay. All right. So we are going to practice the distance formula again in the next lesson, but to finish today, I want to introduce you to a second tool that helps us do geometry on the Cartesian plane. And the second tool or formula is even easier than the distance formula. It is the most wonderful formula. It is so simple, and it's called the midpoint formula. And like it sounds, it basically just finds the midpoint between 2 points on the Cartesian plane. So if I take this question, let me just draw a quick Cartesian plane to go with this. So here is a Cartesian plane. And the point minus 2, 5 would be 1, 2, 3. So that would be the point minus 2, 5. And the point 6 minus 1 would be 1. Let me choose a different color. 1, 2, 3, 4, 5, 6, and then down. So that would be the point over here. And let me even make them A and B. So life is easy to understand. When we want to find the midpoint, okay, between these two, we often call the midpoint M for obvious reasons. It means that we're looking for the point that makes the yellow length equal to the green length. Or visually, we illustrate it like that, like with two little things. We want to make sure those are equal. Now, the glorious news is that the formula for the midpoint formula, so midpoint formula, is just x1 plus x2 divided by 2, y1 plus y2 divided by 2. So that's all the formula is. So if we think about what the points are, this is the point minus 2, 5. This is the point 6 minus 1. If I was computing the midpoint of this, so the midpoint of AB, all I would need to do is I would have two things that have divides by 2, and then I would go minus 2 plus 6, and then I would go 5 plus minus 1. And that will give me the coordinates of the midpoint. Which of the options over here do you think is the midpoint? So you've got a choice between A, B, C, and D. Which one do you think is correct? Which one do you think is correct? Minus 2 plus 6 is 4. But 4 needs to be divided by 2, which means this must be a 2. 5 plus minus 1 is 5 take away a 1, which is 4 divided by 2 is 2. So the correct answer is A. And visually, we can see this point actually is, I didn't do a bad scale drawing. You can kind of see that it's in line with 2 and 2. And that's it. It's as simple as that. What a wonderfully simple formula to find the midpoint. So what we need to do is put this into practice to see that we understand it ourselves. And here is your first, well, let me zoom in a little bit. Can you please find me the midpoint between minus 2, 9 and 3 minus 2? And I want you then to choose whether you go with A, B, C, or D. Okay, off we go. Should I get some water? So how are we going to do this? We go something over 2, something over 2, minus 2 plus 3, and then it's going to be 9 plus minus 2. So that is going to be my midpoint, but I still have to do some simplifying. So what are we going to get? Minus 2 plus 3 is 1 over 2, so that's actually a half. So you can get fractions. 9 plus minus 2 is 7. 7 divided by 2 is 7 over 2, or 3.5. So is there an option that goes with this? A half, 3.5. Oh, okay. So 7 over 2 is also 3.5. And so the correct option should be C. Njabulo, Nomfundo, Kwena, you're looking good. Okay. So, fantastic. I'm getting the sense that we're okay with this. So let's do another one. except this time we're going to have a nice big drawing here. So I want you to find me the midpoint of AB. Find me the midpoint of AB using this. Yeah, and then you can choose the option you think is correct. I'll put the formula at the top for you to use. Which option do we think is correct for this one? I have to watch out. 9/2 is also a mixed number. So I get 1 and 4.5, which would give me C. Well, there's lots of C's today. So that is the answer that I get. I get C. Okay. I think we're doing pretty well so far. Let's do, let's not do that one. Let's do one like this. Okay. I want you to find me the midpoint, just the midpoint between these two coordinates. So this is PQ, and we could say this midpoint of PQ. I want you to calculate what is the midpoint of PQ. What do we get for the midpoint between these two? So we have -3 plus -1, and we have 5 plus -5. That's interesting. What are we going to get as our final point? So -3, take away 1 is -4, but over 2, so I get -2 for that bit. And then 5 plus -5 is 0, and 0 over 2 is always 0. And so the midpoint is the point -2, 0. If you imagine a Cartesian plane, it would be 2 to the left. Okay, so 1, 2, but it would be on the x-axis. And that would be the point. All right, everyone. I think you've done really, really well tonight. We have covered an introduction to analytical geometry, geometry on the Cartesian plane. We covered how to identify points. We covered how to use something called the distance formula, which allows us to calculate the distance between any 2 points. And that formula, just to remind you, it has the structure that looks a lot like Pythagoras, where we have these 2 squared brackets, and then inside them, we have basically the difference in the x and the difference in the y. And then in the second half, we did the midpoint formula, which basically just allowed us to find the midpoint between any 2 points on the Cartesian plane. And this formula was even simpler. It just had a divide by 2 at the bottom, and then I had to add the 2 x's, and for the second bit, add the 2 y's. And that was today's lesson. So I'm just going to put a little